Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aizat Abadi bin Abdul Hadi with my friend Muhammad Luqman bin Yusof and Muhammad Rizal bin Zazi. So today we will do a presentation about our high voltage technology laboratory entitled DC high voltage measurement and monitoring. This is lab 4. So started from the question 1, the arrangement of parallel DC high voltage measurement using FC and picoscope. So this is the arrangement starting from the connecting rod here, as you can see here, which is connected to the transformer, and this is the connecting cup, and this is the floor pedestal. So as you can see here, the measuring capacitor is connected to the floor pedestal and continue at the top with the connecting cup and connecting to the insulating support by using HV diode. HV diode function as its act as rectifier. As you can see here, got two HV diode, and this is the spacer bar at the bottom connecting between the floor pedestal. On the top, connected using connecting rod, as you can see here. The smoothing capacitor function is to reduce high ripple. After that, the smoothing capacitor connected to the parallel resistor and measuring resistor parallelly by using the connecting rod here, and it continue with measuring resistor and the floor pedestal. And this is for the DC HV measurement by using secondary DC unit. As you can see here, this is for the secondary AC unit, and it is for AC HV measurement. After that, this is the insulating support, which is connected to the grounding switch and the top electrode and the iron rod. The iron rod must be touched to the top electrode. And last but not least is the copper braided grounding. It must be grounded meshed to all of the floor pedestal. Next, we move to the complete schematic circuit of SCNDC. As you can see here, the brown one is the live cable, the blue one is the neutral cable, the green one is the grounding cable, the yellow one is the copper braided cable, which is for grounding, and the last but not least is coaxial cable, which is the black one. And the first one is the transformer, the second one is the measuring capacitor, the third one is secondary AC unit, the fourth one which is HV diode, which is two connected connected in series. The fifth one is the smoothing capacitor. Number 6 is parallel resistor. Number 7 is measuring resistor. Number 8 is grounding switch. And number 9 is secondary DC unit. And number 10 is kit FC. Number 11 and the last one is the picoscope. So the connection schematic diagram will show the both connection for the AC measurement and the DC measurement. So started from the transformer, connected to the measuring capacitor by using live and neutral. After that, it connected to the HV diode from the measuring capacitor by using live cable, also connected to the series the HV diode by using live cable also, and continue live cable, and it will continue parallel to the smoothing capacitor, parallel resistor, and measuring resistor by using live cable. As you can see here, the blue one is the neutral cable. The neutral cable from the bottom connected. The neutral cable, grounding cable, and live cable are connected to the secondary AC unit, as you can see here, and out to the banana connector. Yes, and after that continue with the neutral cable here connected in the bottom at the floor pedestal. After that, we continue to the bottom of the smoothing capacitor connected to the parallel resistor and measuring resistor. As you can see here, this is the grounding cable, and the coaxial cable connecting from the measuring resistor to the secondary DC unit by using grounding cable and coaxial cable. For the grounding switch, okay, it continue to the coaxial cable. This is the coaxial cable from the output of the secondary AC unit, which is divided by 2, which is one from the FC, which is VM1. We can choose VM1 to VM4. I think we choose here VM1, and the first one to VM1, and the second one goes to the picoscope. And for the secondary DC unit, it also the same. The output divided by 2, connecting to the VM2, and the other one connecting to the picoscope. And last but not least, the every connection of the such as transformer, measuring capacitor, smoothing capacitor, measuring resistor, parallel resistor, the grounding switch, secondary DC unit, secondary AC unit must all mesh connected by copper braided cable for extra protection to the and connected to here. Yes. Okay, then we'll move to the next one, which is the safety relaxation. Whenever we want to do the discharge process, we must use the latex glove. After that, do not cross between the FC and transformer because there are too many wires, so it might be dangerous. The third one is every floor pedestal must grounded by using copper braided cable, like I said just now. Last but not least is to ensure the rod on the grounding switch touching the top of the electrode. As you can see here, this is the iron rod touching the top electrode. Thanks. That's all for me.
Section 2. Number 1. Source control. Based on the figure show that the manual setup had been set to determine the source control. The main command window of the source control can be displayed by clicking the setup and choose the customer setup. Then for the manual step of source control, it will display in the customer setup setting. There are 3 different gain, first in single gain, double gain, and triple gain. For the experiment, we set the single gain to 0.1, double gain to 1, and triple gain set to 10. Number 2, primary side of the transformer progress. Scope for primary including voltage and current. Figure show that primary side of the transformer voltage and current. This is example of the 10% gain. The data graph will show the voltage and current increase when we increase the voltage and current at the primary side of the transformer. Number 3 is system monitoring of secondary side of the transformer with 8 slot. Based of Based on the left figure show that the system monitoring in frequency monitoring setup. For this system monitoring, RMS and RMS1 is connected to the VM1. For the peak over square root 2 and RMS2 are connected to the VM2. For the MIS3 is connected to the VM3, and for MIS4, MIS5 and MIS6 are connected to VM4, VM5 and VM6. Based on the right figure from the left to the right, the example of the slot VM1 until VM6. Number 4 is alarm system. Based on the left figure show that the alarm is in the red color condition. It means that the supply cannot be injected and the testing and the experiment cannot be implemented. The pop-up message will appear in the window as in figure. The alarm turn to the red color because for the several reason. For example, when the door not closed tightly. To turn the alarm to the green condition based on the right figure, we need to ensure that all procedures are in good condition and safe. After that, make sure the door is closed properly and the emergency button is released so the sensor can be activated, so the alarm button will change to the green alarm button, which is it indicate that the system is ready for the injection process. For the customer setup, we have to set some of these criteria, which is manual step, impulse sequence setting and calibration. For the manual step, there are 3 gain that we have to set, which is single gain, double gain and triple gain. The example of this experiment had been produced are 0.1, 1 and 10. There are 3 values to be set, which is high signal, pulse cycle and pulse trial for the impulse sequence setting. For this setting, for high signal, the value we set is 1 second, pulse cycle is 5 second and pulse trial is 5 second. Based on the figure show that the calibration setup for VM1 and VM2, the instructor only activate 2 channel, which is VM1 and VM2. VM1 slot can be determined on the setup as RMS and RMS1, while VM2 slot can figure as peak over square root 2 and RMS2. For the testing, the serial number for this secondary part is S over N 150 at 228. So for the value of voltage divider to be set in VM1 slot RMS is 19651.1. Based on the figure show that the display of Picoscope 3000 series. Picoscope has 4 channel, channel A, channel B, channel C and channel D. In this experiment, to produce the value of the graph in this experiment, we just channel A. Firstly, we must set the acquisition samples from 0 to 100k. After that, from 0 to 100k, each number will be determined as a sampling point in one period of sinus wave. Secondly, the sampling interval must be set. Then, the sampling interval must be set to 10 micro. After that, set the channel coupling to AC because this experiment will determine in AC. The range set to 10 volt because the maximum measure value of this frequency converter is 7 BRMS. Then insert the divider ratio, which is the value is 19651.1. Lastly, for the offset, set to 0 for the normal condition. After that, the last setup, we have to click reset to do the project testing.
Assalamualaikum warahmatullahi wabarakatuh. My name is Lukman. I will continue present about the section 3 comparison for analyzing the different signal from kit control and display signal from Picoscope. Next slide is the showing of the result table that I've been measured. I've been taking the reading and the calculation. The value for the output voltage has been given to take is 0, 10%, 20%, 30%, 40% and 50%. As you can see, the value for the reference and the display is quite similar. just a few point different, maybe 1.0 different for each percent. For the frequency, all is being given for 50 Hertz. As you can see, the error percent, the calculation has been given the formula reference minus display divided by reference times 10% of to get the percent. And as you can see, the error percent, all of the result is probably most of them are negative in value. Next, I will present about the different. The difference is between the reference and displays, as I say before, is quite similar, both value, the reference and display, but there is still a different, even though it is different 1.0 or 0.5, still have the different. Then I can make a discussion about the result that I've recorded at the table above. As we can see, the value of the reference and the value of display means it's almost similar, even though the value is almost same, but still it has the different. It is because the resistance effects and also the output that come out from the frequency converter, and it's also condition of the environment that we can run from it to it happen. This error will also cause the error percentage value of to fluctuate. There is also a value of less than 10%, and the value become negative. To overcome this error, we need to keep all the equipment or apparatus functioning well and clean. Next slide for the conclusion. From this experiment, we can conclude that upon completion of this experiment, we were able to construct a parallel DC high voltage measurement by using kit control 4.0 and picoscope 3000 series. The construction of the circuit is much easier when using these advanced technologies. It helps to get the result using only one equipment that contain all features that we need to completing every task in this experiment. Furthermore, we can be familiar with the procedure of the setting of the kit control 4.0 and picoscope 3000 series. This is because we are given a task that need to fill up a table and need to repeat every value that is needed. Lastly, we were able to compare and analyze the value that obtained from kit control 4.0 reference and picoscope 3000 series for the display. That's all for me and my team. Thank you. Assalamualaikum warahmatullahi wabarakatuh.